Hi, in this video we are going to implement the remove method. So we are going to have a remove method. We specify the node or the data we would like to get rid of. If this given linked list is empty, which means that the self.head is a none, we just have to return. We are not going to get rid of anything. Anyways, we just have to decrement the size, so the size is equal to the self.size minus 1. And then we store a reference to a current node, which is equal to the self.head. We will have the previous node, which is equal to a none at the beginning. And basically, we have to write a while loop. So while the current node dot data is not equal to the data we are looking for, we're just going to update the previous node and the current node. So the previous node is going to be updated to the current node, and the current node is going to be updated to the current node dot next node. So basically we hop to the next node. And after this while loop, we know that we are at the node we would like to get rid of. So if the previous node is a none, it means that we would like to get rid of the root node or the head. So self.head is equal to the current node dot next node. So we just have to update the references. And else, we know that this is not the head of the linked list, so this is not the first node. So the previous node dot next node is equal to the current node dot next node. This is what we have been discussing in a theoretical section. Let's suppose the fact that we would like to get rid of 10. 10 is approximately at the middle of the linked list. First we have to look for it. So we have to iterate through the linked list and have to search for that given item. And whenever we find it, we just have to set that the previous node is going to point to the next node of that given node. So that's why we just have to get rid of this reference. We have to set it to a null. And anyways, we just have to tell the -7 to point to 25 directly. Okay. So this is how we update the references, and this is what we do here basically, that whenever we find that given node, we just set the previous node next node to point to the current node next node. Okay, so this is why we update the references like this. And in this case, we know that if the previous node is a none, we know for certain that the current node we would like to get rid of basically is the root node or the head of the linked list. So we just have to set the head to point to the current node next node. Okay, so that's all about the methods as far as linked lists are concerned. In the next video, we are going to test our linked list data structure. Thanks for watching.